Hello, everyone. Welcome to our webinar today on optimizing for application performance with Amazon CloudFront. My name is Julius. I'm the CEO and co-founder of CloudWiser, and we are your host today for this event. For those who do not yet know CloudWiser, just a brief idea of what we are and what we do. We are advanced tier AWS partner operating in the Baltic countries. That means Lithuania, Latvia, and Estonia. And we have very special focus on AWS Edge services like Shield, CloudFront, WAF, and that's why you see CloudFront and WAF mentioned in our AWS partner badge, because we're focusing on that, are accredited on especially those services. And actually CloudFront, our main service of today's webinar, it's a very special service for us. And I hope that after the presentation today, you will see CloudFront as a special and very good service as well. And actually, while talking to customers that are using AWS, I see that CloudFront is actually quite underestimated service, and it's usually perceived as like pure CDN. If you want to deliver video, images, and then like all kind of static content, yeah, that's good. But actually, there's a lot more around the service connected to, first of all, of course, security, and to dynamic content, and then with focus and idea to talk about that part which is not so widely known or so widely used, we decided to do this webinar, and we'll be focusing mostly on dynamic content, on Lambda and Edge, and then what kind of cool things we can do with all of that. Yeah, so don't take my word for it. We have people from AWS that will talk more broadly and in more detail about these things. Just before we begin, a few logistics details that you should have in mind. So first of all, we will be recording all of the presentation and sharing it with everyone. So please have in mind that afterwards you will have an opportunity just to look through the slides, the questions, and then the discussions. And the other thing, questions are very welcome. There's a special Q&A section at the bottom if you see it. And we'll try to stop after like each main part of the presentation and go through the questions and of course expect a broader Q&A discussion at the very end. So please go ahead and submit your questions in the Q&A part, and once we stop, we'll go over them and try to answer them as best as we can. Our speaker today will be Rohan from AWS, solution architect from AWS, focusing specifically on the Edge services. And I'm very happy that he found the time in his schedule to talk with us and then to present the things that we'll be seeing here today. Rohan, are you ready to take over?
Sure. Thanks, Julius, for the introduction. Let me share my screen as well.
Already, I even already see some questions in the Q&A. Very good.
Oh. Okay, let me know if everyone can see my screen.
Mm-hmm. Yeah, I see it. So I guess.
Okay, great. Okay, so yeah, as Julius mentioned, today we are going to talk about on how you can use Amazon CloudFront for delivering your application in the most fastest way possible, and that's where CloudFront comes into play. I'm Rohan Raizada, working as a solutions architect here at AWS, and we also have Ashraf, who would be available for the Q&A when we have done with the session, to answer any questions that you have around the services that we are talking about, which are CloudFront and Lambda Edge. So to get started with, what you see here on the screen is the Amazon CloudFront. So Amazon CloudFront is a service which you can use to deliver content for your end users. And what you are seeing on the screen right now is it gives you a high-level overview of our global presence. So the dots that you are seeing on this screen right now are actually points of presence. And we have in total 216 points of presence, or edge locations, you can call them. And these edge locations are typically closer to your end users. This is in different cities around the globe. And on top of that, we also have around 11 regional edge caches. And what these regional edge caches allow you to do is these regional edge caches sit between your end users and the origin server. So what they allow you to do is they allow you to cache the content and give you a bigger probability of having a higher cache hit rate. And what you also see on these screen, as you already saw earlier, these lines are actually our own private backbone network. So this is fully managed by AWS. It is a global backbone network that's managed by us. And I'm going to give insights later into the talk about why this is significant and some of the things we are thinking about as we deploy this global network. And one of the other things is we have been growing at a very aggressive rate. So what you see on the screen right now is we have been growing at nearly 50% year on year. So right now we are present in almost 84 cities and 42 countries. And anytime I have to present this content, I need to update the slides with our points of presence and edge locations count. And as you can imagine, because we are deploying our own private backbone network, our edge locations, we are also doing a lot of optimizations. We have the opportunities to do those optimizations both at the network layer as well as the server layers, which we are deploying on our own hardware. And we'll talk about them in the coming slides. So one of the things which customers ask is, or you should be asking is, why does performance really matter, right? And one of the things which we are hearing from customers is that if you are serving an application, a web page, if it's taking a lot of time to load, that's not good for the end users. And one of the statistics is that on an average, a visitor will just spend around 2 minutes. And if the page is not really loading for them, they will just move on. And if you are delivering this content, that's not really great experience for your users, because your users are not really sticking to what you are serving them. Then the other thing is also around search engine optimization. You have these search engines and they have the crawlers, which usually go and visit your web pages to index your websites. And they will, these crawlers will also spend a certain amount of time on the page to index it before moving on. And again, as with the earlier one, if it takes a lot of time to load, it will be able to index less, and there is a very likelihood that your all the pages are not indexed, and it reduces your chances of showing up on search results, again, which is not good for business as well. And the last thing here is over the last couple of years, we have seen a lot of streaming workloads, right? The world is moving towards OTT, over-the-top delivery platform for the delivery for both live as well as on-demand video delivery. And one of the things is we are hearing from our customers is that they're looking to have the capacity as well as the scale to support these workloads. And they don't want their end users to suffer because of buffering issues. And that's where the CloudFront can help you with all of these issues. So just to give you some examples of what customers are doing right now with CloudFront, I already talked about they are using, you can use CloudFront for storing static content, but we are also seeing customers use it for a lot of downloads. These could be your game downloads, application downloads for delivering of your entire application infrastructure or your websites. We have some customers, for example, Slack, which use it for their API acceleration. A lot of customers, as I mentioned, in the video streaming space are also using CloudFront. And the other is the capability what you see here, the programmable CDN. This is the Lambda Edge, which allows you to offload a lot of your processing to those edge locations, to those points of presence. So there is less that you need to do at the origin server and what you can rather do at these edge locations using Lambda Edge. And we'll take a look at some of these Lambda Edge use cases in the coming section as well. And as you see in this slide, this is just an example of some of the customers. And you can see here a lot of media customers, for example, Prime Video, Hulu, Sky News. These are using it for video delivery over the OTT delivery. Then we have customers like Slack using it for API acceleration, as well as other customers here as well, which use it for downloads, for static content storage as well. So moving on to the Amazon CloudFront Global Network, right? So I already showed this picture in the map earlier, right? So, and I mentioned about this backbone network that we actually as a AWS are operating it privately on our own. And one of the things which is very important here is that especially for CloudFront as a service is this allows us with a consistent, or this gives us with a consistent, reliable performance. And we are going to dive a bit more into that later, but just to give you one analogy, right? So for example, I'm a solution architect and I have to go and visit customers in different cities here in the EMEA. And one of the things is when I'm going to visit them, I usually reach the airport, and obviously to reach the customer office, I can rent a car, and then maybe I'll hit the road. And if I'm lucky, then maybe I'll have all the lights as all the traffic lights as green. Maybe I'll hit some of them the red lights as well, and hopefully I'll be able to reach on time. But if I hit it at a wrong period of time, then I'm definitely not being able to reach the customer office or the location in the right time. And the same is with other medium. I obviously could take the highway as well, but again, if I hit it at the wrong time of the day, that could add more delay, and I'll not be able to reach the office in time as well. And then there is this other option wherein I go to the airport, and there is usually a subway or a metro, and I can go and hop onto those. And these are pretty good. There is a less likelihood of me hitting any traffic issues or any congestion issues, and I'll be able to reach the destination on time. And even if, for example, one of the trains is running late, there is another train which is going to the same destination using some other path, and it will allow me to reach my destination on time. And that's exactly the same analogy what you have with this CloudFront global network. So you can think of this global network as this sophisticated subway or a metro system, which allows us to provide that reliable performance to the customers. And this allows you to make sure that the content gets delivered to the customers in the fastest possible way. So, why do you need to leverage AWS backbone network, right? So one of the first things which is important here is that it allows us to provide better availability in terms of that network path, right? So for example, I already gave an analogy of the subway and the road traffic or hitting the highway. When we are operating this backbone network, we want to ensure that we have multiple paths to get to the same destination. And once you are on our backbone network, we are able to understand things, for example, like where there is a more likelihood of certain fiber cuts happening. And once we know that, we can lay down more fiber on those particular points, as well as we have truly redundant paths on top of that. Besides that, we are also looking at capacity and scale, operating the traffic on our own network. So this allows us to scale based off our understanding of how our customers are using this. Instead of relying on transit centers, which typically scale based off traffic patterns that they have seen historically. And the other thing here is also around performance, right? So what we are doing as part of this is we are continuously monitoring and optimizing these paths from one point to another. So we are not just looking at the primary path, right? Because the primary path, there are a lot of things which can go wrong in any network path, right? Congestion can happen. There are fiber cuts. And what we want to ensure is that there is reliable performance. So what we are also doing is we are measuring and monitoring those secondary paths as well, so that we know if there is an issue in the primary path, we know how to get to the destination using one of those other secondary paths. The third thing is proximity. Having a global backbone network allows us to be closer to our customers in certain parts of the world. We are limited in the number of options we have for connecting to these networks. And having that particular backbone network allows us to open up our options. And we can do things like our own traffic engineering to route ingress and egress traffic to the different cities. Which helps us overcome things like congestion at different internet exchanges, or even sometimes peering disputes. And the last point is primarily around security. And I think this is rather one of the most important things because we are operating our own network. What we can do is we can do things, for example, like DDoS detection or look for bad signatures. And based on those, we are filtering out the traffic based on those malformed requests. And once it's on the backbone network, we know and manage, and we are taking responsibility for the security of it. And one of the other important things, as you already see here, is that all of the backbone traffic, all the region-to-region traffic uses this backbone network, except for China as well. So with that said, let's take a look at some of the network optimizations that we are doing. So as part of this, let's say you have a viewer, right, which is trying to access a site. In this case, we are calling this site example.com, right? The first thing which happens is they make a DNS query. It typically goes to their ISP resolver. If the ISP resolver doesn't have the answer, it will forward it recursively to a Route 53. And Route 53 will see that this belongs to a CloudFront domain. And it will send it to the CloudFront to resolve it. And when we do this, we are actually looking at a number of variables. So for example, what we are doing is we are looking at things like performance, right? So what we are doing here is we are looking at the round trip time of the TCP handshake from all of these end viewer networks around the world to our different edge locations. And we take around 1 billion of these samples every day. So we understand at any point of time what the connectivity looks like. And we can understand network congestion and decide accordingly which is the best location or the edge location to serve this request from. We are also looking at the POP health, and this is especially true when we are doing maintenance tasks. We don't want to send the request to a location which might be undergoing hardware refresh because we are continuously upgrading our edge locations. Besides, we are also looking at server capacity. This is important because you don't want to send it to a server which is about to reach its capacity in terms of IO or CPU. And also, we are looking at the network capacity. We are monitoring these. We are monitoring the links to the different networks, and we want to make sure that we are not sending traffic to our edge location, which might be close to flooding their links. So with all of this information, right, we can provide an answer in real time to the client, and then the client can go ahead and make a connection. So this is primarily around intelligent routing. So the next optimization on the network layer, which CloudFront does, is primarily around congestion control. And as I mentioned, performance is really important, right? What we want to make sure is that we are sending the data back to the viewers or to the clients as quickly as possible, right? And achieving the most optimal throughput on that last mile connection. And I think with with the TCP, which is the transmission control protocol, you know the latency for the round trip time of sending a packet from one point to another, right? It is basically the length of the pipe. That's essentially the round trip time of what it would take to send it to a server and get it back. However, if you notice on this diagram, all the pipes are not of the same width. There are certain pipes which have a smaller width or those bandwidth limits. So if you send too much traffic, you could hit into those buffer issues at one of those points along the way. And even worse, if you send too much traffic, right, what you can do is you can have issues like packet loss. And the way the TCP operates is we have a lot of algorithms for congestion control. And what we can do is we can understand how best to avoid that congestion control. So for example, the typical congestion control algorithm like Cubic will actually scale down and gradually ramp back very slowly. So that doesn't allow us to give the full pipe bandwidth limit that is possible with the existing congestion control algorithms. And that's what we have been doing. We have been playing around with these congestion control algorithms. And one of the things which CloudFront did earlier was we deployed a new congestion control algorithm called as BBR, bottle bandwidth and round trip time. And what BBR does is it manages the control, the congestion control based off the actual congestion and not based on the packet loss. And how it does that is it's measuring the round trip time and the bandwidth limit along the path. So it's looking for that particular bottleneck bandwidth limit, and the round trip time is ideally going to be the length of the pipe. And it's probing the network to identify what the most optimal round trip time should be. So it is also probing for changes, because traffic engineering can, it happens, the paths might change. So it's also sending a bunch of packets to identify if the bandwidth limit has increased or decreased. So by doing this, it's able to kind of rapidly change the congestion window and adjust accordingly. And in doing so, the end goal is to saturate the bottleneck limit. So the router along the way with the lowest amount of bandwidth, we want to send as many packets as possible up to that limit. So that's one of the optimizations which CloudFront does. And just to give you the effect of what using this TCP congestion control algorithm allowed us to do, when we deployed it, is one of our customers, actually Tutela, which actually monitors these impacts. We almost noticed a 20% increase in our throughput limits. Without going too much into further details, we also have a blog post around this. So if you want to take a look at that around the effect of these congestion control avoidance algorithms on CloudFront, you can refer to the blog post. So the next topic here is around TLS, right? So as you can imagine, security is really important, right? And one of the ways customers are ensuring security is to make use of TLS. One of the things which we have noticed is in our CloudFront and our backbone is the TLS traffic has been growing at a rapid pace. I mean, it has almost doubled over the past couple of years, and it is close to 100% of our traffic. However, when you do TLS, it typically adds a latency. And when you are a CDN, the job is to increase the performance and reduce the latency for workloads. And one of the things is primarily around with the existing TLS protocols, is that continuously these protocols have newer versions, newer changes, and it is difficult to keep pace and deploy how these are going to affect the performance of your TLS encryption. So one of the things which we did with CloudFront earlier was we launched our own library for SSL called as S2N for TLS. And one of the advantages it allows us to do is that an existing TLS library would have about 600 or 500,000 lines of code. Whereas with S2N, we are actually just have reduced it to around 6,000 lines of code. And this allows us actually to react quicker to security patches and also deploy those changes. Besides, because we control, we have full visibility into the source code, it allows us to review the code with more scrutiny. And actually in deploying, what we are seeing is once we have deployed S2N, we are seeing less event blocking in our termination servers, which gives us actually more capacity at our edge locations. So if you look at this particular example, right, and I already mentioned this earlier, that TLS has an overhead. It comes at a cost. So this is this extra handshake which happens after the first TCP handshake. So typically you have a couple of handshake as you would imagine from your school days, right? The first part, you get the server certificate, and then you need to negotiate about what algorithms or what cryptography you are going to use to do that encryption on the subsequent messages. So in the second round trip is actually the exchange of these particular keys. So you are able to do things, for example, like perfect forward secrecy. So there is a lot of value in that, but again, it comes at a overhead of that particular additional round trip time. And that's really not good. So one of the things what we added or the TLS has is this capacity or capability called session resumption. And this is what we have implemented in CloudFront. So what this allows us to do is, for example, when a client connects to CloudFront, we also hand it a session ticket. And this session ticket is only known to the server. And this is typically, this session ticket contains a bunch of cryptographic information about the security profile of the original connection. And then on subsequent connections, what happens is when a client goes on to resume a TLS connection, then what happens is they can just send a hello along with the session ticket. And we do certain validations to make sure that this is indeed the session ticket which we handed over to the client. We can just establish a connection with the server quickly without an additional round trip time. So we are able to reduce one whole round trip time from the initial or from the subsequent TLS handshakes. So this is one of the added benefits which CloudFront allows you to achieve. So moving on, so I already covered a lot of content around network optimizations, right? But what about server optimizations? In this part of the talk, I'm going to talk about server optimizations. And this is primarily around on how you can use it for optimizing dynamic content delivery, what additional things which we do for media, as well as reducing the load on your origin servers. So if you look at caching, it seems very easy, but when you actually implement caching, it is one of the hardest problems in computer science. And one of the key goals there is that you want to reduce the latency for the incoming requests, right? You want to increase the cache hit ratio. So you want to have more amount of content cached in your servers so that there is a higher probability of it being available in the cache, and also reduce the cache miss scenario so that you don't have to go to the origin when you need to go and fetch that content. So it seems simple, but when we actually implement caching, it is one of the hardest problems in computer science. So just to give you some idea of how CloudFront tackles caching, or what we do cache on how do we effectively utilize our cache space. So what you see here in the diagram or on the architecture here is, this is the architecture of our edge location of our POPs. And as you can see here, there are a lot of servers from server 1 to server n. And each of these servers has 3 different layers of proxies. And we call these layers as L1, L2, and L3. And what happens here is that the L1 acts as a load balancer, and it only keeps those hot objects in its cache. Those hot objects are typically the objects which are very popular, and these are the most frequently requested objects from the viewers. The other layer is L2, What it has is it is a caching layer, and the sole purpose of this layer is just to read and write from cache. The layer 3, which is L3, it does not have any cache at all. What it does is it just maintains a connection pool towards the origin as using those persistent connection mechanisms. And we'll see the benefits of these later on. So just to give you an idea of what happens, right? So for example, when a request lands in, right? So at the L1 host, it looks at the configuration and to make sure that the request actually came for a valid customer. And once it decides that it has to satisfy the request, it would do the TLS termination. And once it does the TLS termination, it would immediately look into the hot object cache to see if it is in the cache. If it is not in the cache, as you can imagine, it will send it to the layer 2 or the L2 cache to see if any of those L2 cache servers has that content. However, these edge locations can have n number of servers, right? And you don't want to send them to any random L2 servers, because if you do that, you are unnecessarily replicating the content, and your chance of getting a cache goes down drastically. So what we do here at the CloudFront is we have implemented a consistent hashing algorithm. And this consistent hashing algorithm uses a URL as the key for the consistent hashing. And as a result, if the request lands on any of those L1 servers, we would do the consistent hashing based on the incoming URL, and we will end up picking the same L2 server. So we are optimizing for the cache hit rate, and we are also reducing the unnecessary redundant data storage in our cache servers. And let's assume in a scenario that the content is not there in our L2 servers at all. Right? In that scenario, what happens is it will go to the L3. The L3, as I mentioned earlier, maintains a persistent connection to your origin. In this case, the origin is S3 bucket, but it could be any origin. And this L3 server makes a connection to the origin. So at the L3, what we are also doing is we are optimizing for connection pooling. So what we are doing here is when we do this, instead of opening 100 different connections to the origin, we are also using another algorithm. So in this case, we don't use a URL as the key, but we rather use the domain as the key to maintain that particular hashing algorithm. So that all of the domains for which that persistent connections need to be made, it ends up on a single L3, and that way we get a good hit rate on the connection pool. So this is how our caching request flow looks like. This is especially useful for dynamic content acceleration, right? So in this case, as you can imagine, with dynamic content, you're not storing the content, right? So just what happens is when a request comes in, the TLS termination happens at the edge. It lands on the L1 server. We do certain validations or checks to see if the content is cacheable or not, based on the distribution settings, the CloudFront distribution settings that you have defined. And we will know that this content is not cacheable. So we totally bypass the level 2 cache and send it directly to the layer 3 cache or the server in this case. And this allows us to reduce or skip a step and go directly to the origin. And this is really crucial for better performance and improving the throughput as well. So, just to give you some of the benefits of these persistent connections. One of them is around when we reuse these persistent connections, we don't have to reopen those connections, the TCP connections, because again, as I mentioned earlier, with the TCP, there are handshakes which happen, and it takes a lot of time. So we avoid all of that. And we can reuse an existing the TCP connection, and we get the entire response. And this allows us to achieve better throughput. So just to give you one example of one of the customers which actually used of one of the real customer case studies. So Tinder, I think everybody knows Tinder, and I'm sure maybe some of you are using it. So Tinder was having these latency issues from across the globe. And just to give you an idea, so they had their origin hosted in the US East region, the North Virginia, and customers were, let's say from Indonesia, they were seeing a latency of around close to 500 milliseconds. And this was because they were not using any content, any CDN in this space, and they were only using the internet to route traffic to the region where the content was hosted. And this led to a bad customer experience. And when they implemented Amazon CloudFront, what happened was their end users, they got mapped to a very nearest edge location in Singapore, which took almost close to 70 milliseconds. The TLS termination happened at that point. And from Singapore, as I mentioned about, it used the Amazon Global Backbone Network, and it used that to reach to the origin. So the total time reduced from 500 milliseconds to 285 milliseconds. So with that said, how does CloudFront can help you with media delivery, right? So with CloudFront, we have delivered some of the largest media events last year, and these are just some of the examples what you see here. However, the media delivery has its own challenges, right? So for example, whenever a popular event is about to start, everybody starts watching the event at the same time. And what this ends up doing is it ends up sending a lot of requests to the same part in that particular region. And this causes a unique problem in the CDN world. And this is something called as the flash crowd or the thundering herd problem. So with some of the terminologies that I explained earlier around on how our POPs are tiered using level L1, L2, L3, let's see what effect this has on the architecture. So let's assume we have a lot of flash crowd coming in, right? So maybe in this case, we are just taking an example of a Super Bowl event, and a lot of requests came in. So what will happen is that these requests will end up getting spread over the layer 1 server. And these layer 1 servers, as I mentioned earlier, is they are trying to optimize for hit rate, right? So they are going to forward the request based on the same consistent hashing algorithm to a L2 server, in this case to a single L2 server. However, in this case, what will happen is because there are so many requests which are going to come, the optimization or the architecture that we did earlier is actually going to work against us, because now this L2 server has been flooded with so many requests, and it's not going to be able to take that much additional load, and it's going to go down. And the same with for the other servers as well. And this leads to a cascading problem, right? Because all of your L2 servers are getting flooded, and this is not something which you want to achieve in the architecture. So one of the things what we did as part of this is to avoid this problem is we added, or to improve our consistent hashing algorithm, we added a lot more data. So one of the things we did was we added 2 properties. One is to track the popularity of the object that each L1 server is serving. And the second, we also taught those L1 servers to learn about the load of each L2 server. So for example, when the L1s started sending the request to L2, it can immediately understand that the L2 server is at a very high capacity and it cannot handle any more requests. And what it will do is it will decide to send that load across to other available L2 servers. And this helps us to serve the content to our customers and keep the streaming going on without any buffering issues. And that's what we are doing, especially for media delivery. So one of the other things which happens is, as I mentioned, when this flash crowd comes into play is whenever an event is starting, the viewers are watching the media for the first time, right? And so nothing is in the cache because that's the first time these media is being delivered to them. And so that all of these requests will end up going to the origin, and layer 3, as I mentioned earlier, is the layer which maintains a persistent connection to the origin. So they are going to start overloading the L3 server. And what we do here is, again, as I mentioned earlier, is the L2 servers are smart in the sense that they understand that all these requests are coming in at the same time, are for the same content, for the same object. So they decide not to forward all of these requests to all of these L3 servers. And what they do is it's just going to collapse those requests and just send one of those requests to the origin. Yeah, so the other is around caching, right? So let's say when we get the response back from the origin, right? We send the response back to the layer 2. The layer 2, as I mentioned earlier, has a huge cache width, so it will cache it immediately. It will send it all the way to L1 as well. And the L1 can understand that this object is really popular, and it will be able to cache it because it also has a small cache footprint for storing those hot objects. So it also caches it in the L1 layer. And from this point onwards, any other new customer who is watching that particular event or a video stream will not even reach the L2 server, but will just serve the content from the layer 1 server. And that's the best case possible for our customers, and it provides the best latency and gives the best performance as well. So the other thing is, I mentioned earlier, we have 216 points of presence, right? And we are continuously expanding this number. Because we are continuously expanding this number, we have more POPs and edge locations. And the end result is that the customer's origin might start seeing a lot more load. So to reduce the impact of this, what we did, and one of the ways is, if we didn't have any mechanism, is you can obviously need to scale your origin server because we are sending more traffic to your origin server. So one of the changes which we did was introducing regional edge caches. And these regional edge caches, these are the intermediate component between your edge locations and your origin server. And one of these advantages which these regional edge caches have is they have a huge cache width. So they can have a lot more cache capacity as opposed to edge locations. Then what it also does is that these edge servers, they send the first request when they themselves don't have the content to these intermediate layers. And if the intermediate will most likely have it because of the huge footprint, and it also collapses the amount of requests sent to your origin server. And this in turn reduces the origin load, and it increases the cache hits for the customers, thus improving the latency as well. And this is just a sample graph I wanted to quickly highlight of when we introduced regional edge caches. So the blue line here was the traffic which was served from regional edge cache, right, before this feature was introduced. And what we see here in the green light, in the pink, is the origin bytes was just 3.6 petabytes. So we just had to fetch 3.6 petabytes worth of data, and we saved customers. We didn't end up going to the origin to fetch that additional 8.5 petabytes of data being pulled from the customer's origins on a daily basis, which is a huge win for our customers as well. So with that said, I think I would stop here for a moment. In CloudFront, we say that every millisecond counts, and we want to have the best performance, minimal latency, and without any buffering issues. And we want to see the smile on our customers as well. And with that, I think I'll give it to Julius to do a small, like a quick poll.
Yeah, thanks, Rohan. As agreed, we'll just, to see whether you were listening attentively, just a small poll, and please submit your answers, and then we'll share the results with everyone, and the correct answer as well, for sure. Also, Rohan, I saw that we have a few questions, so maybe we will cover those now. What do you say, or would you like to do that at the end?
I think we can take those questions as well, yeah.
Okay, so let's just give 10 more seconds for everybody to vote, and then we'll share. Okay, I'm ending the poll. And you should see the results. So most of the people were listening very closely, and then named the right result, that it's 216 pops. I remember that last year it was like a huge milestone for AWS and CloudFront when you passed the 200 points. I think it was somewhere in South America, if I remember correctly. Exactly.
Yeah.
Okay. Yeah. So we have two questions. One is from Lorinas. His question is, we use CloudFront with Angular router. Because of that, we had to create a custom error page that redirect 403 and 404 error codes to index.html. Is there a way to remove these custom error pages, because now we can't see the real 404 errors?
So
can help with that?
So you were saying that, so in this case, you already are using CloudFront and they are serving the content, right? And then there is this error page, which is configured in CloudFront. Julius, is that right? Or
I understand this way. Maybe Lorinas can confirm it on the chat.
Because one of the things is, till the time you're confirming that, is that the CloudFront also allows you to specify these error pages, and these error pages can be stored in S3 to be served with a custom message, and where this could be a custom message to be to contact the customer care service or anything. And then one of the things which we'll do in the coming section is we can obviously use Lambda at Edge as well. And I'll cover some of these use cases in the coming talk, in the upcoming section.
Yeah, I see Lorinas confirmed that it's a custom CloudFront error page that simply redirects to index.html.
But then why are we trying to redirect it to? Because the error page should be served when the origin sent an error, and instead of just sending 404 or 5xx back to the user, you want to have an end user a better experience serving a custom error page telling about the problem. I mean, I won't say to get rid of it, but if you cannot really serve index.html page, then in that particular scenario, it's always a good practice to serve a more user-friendly error page telling them to retry after some time, or contact some agent, because it's happening consistently.
Okay. Yeah, so Lorinas, like if you would like to dig deeper into this topic, just as you have my contacts, just write me an email, and I'm sure we can arrange some deeper discussion. But yeah. And we have one more like short, quick question, which I heard a lot from our customers, is does CloudFront perform better with S3 as origin?
So, so again, so CloudFront is agnostic to any origin, right? So the origin could be S3, it could be EC2, or it could be your own in your own data center. I wouldn't say that it performs better as an S3 or as an origin, just that the S3 has its own scale, right? The benefit is it is redundant. We give you a lot better availability and durability. And once it hits our backbone network, it is in our region where it is. So I would not make that claim that it performs better with S3 as origin.
Okay, okay. So that's all questions we have at the moment. So I guess we can move on to the next topic,
Okay,
Lambda Edge.
great. Yeah. So moving on to the next topic is Lambda Edge. And I mentioned about in the earlier talk, in the very first slides, programmable CDN, right? And that's what the focus is here. So I think everybody would be using Lambda, I'm assuming. And one of the advantages with Lambda or serverless is you have no servers that you need to worry about provisioning or managing, right? The other is depending on how your pattern is, if it's growing linearly, the serverless can scale as well without you worrying about provisioning additional capacity. The third other benefit is you don't have to pay for resources when they're idle, as opposed to running servers where you are always paying. With serverless, you only pay when event or a request comes in and you're doing something with that. The last is the availability and fault tolerance are built in. With servers, you typically have to provision it in multiple availability zones, have additional failover setup. With serverless, again, all of these issues are something which AWS takes care of. So when you think about serverless applications, there are three components to it. One is the function itself, in this case, Lambda, and the Lambda supports different runtimes, as you can see here, and it also has the flexibility to bring your own runtime. And then there is, it can make a call to anywhere, any external resource. It could be AWS services or anywhere out on the internet. However, the trigger in this case is event source. So this could be any event, something like there is a change in your data state, any database, or it's an incoming request, or one of your resources changes state. So based on that event source, the function gets triggered and it can make a call to those services and then send the result back or do any processing. So that's serverless in a nutshell. And if you look at Lambda, we support a lot of those trigger sources or the event sources. And what you see here on the screen are just some of the event sources. And the focus here as part of this talk is primarily around Amazon CloudFront. So if you look at Amazon CloudFront, we already talked about it earlier. If you use that as an event source and apply it to Lambda and use Lambda capability with that, that is usually what Lambda Edge is. And that's what we are going to talk about in this scenario, in this part of the session. So what are some of the benefits of the Lambda Edge? So again, all of the benefits that I just touched earlier, they actually hold. And one of the added advantages which Lambda Edge provides is it's globally distributed. So you're not just running Lambda in a particular region. When you use Lambda Edge, you run it across all of those points of presence or edge locations. And this in turn allows you to bring your code closer to end users to improve the experience. So one of the things is that what you can do is when you use Lambda functions is that you can author your functions only in North Virginia, especially with Lambda Edge. You just create those functions, but when these functions are deployed, these are deployed on the POPs or the edge locations closer to your end users. So that's just a additional point which you have to take care of when using Lambda Edge. And as I mentioned, you can use them anywhere else. So what benefit does all of this give you? Why CloudFront plus Lambda Edge? So if you look at this particular example, right, let's say you have an origin. The origin is in US East, North Virginia, and you have an application running there, right? So the application will have compute, it will have a storage component, it will have a database component to it. And if you have, let's say, a few users connecting to your origin from the same geography, this all works pretty well. But if you're talking about your global application, as you can see, this is not a very optimal state, right? You will have performance issues, latency issues, and that's where to solve that particular challenge, the CloudFront comes into play, right? So your customers, we give you certain amount of storage capacity at those edge locations to be able to cache that static content. However, now your end users can connect to these edge locations. The content is cached. All of the static content can be cached, and it can be served closer from where they are, as opposed to going all the way to the origin. So one of the things which Lambda Edge adds is it also adds this compute capacity to these edge locations. And we will see what this advantage gives you in terms of the use cases where you can use this. So let's start diving into Lambda Edge. But before I go into the specific use cases, I just want to make clear some of the terminology. So in this case, we have your end user, again, just one viewer, but it could be hundreds of thousands. You have your CloudFront edge location, and you also have your origin, right? It could, as I mentioned earlier as well, the CloudFront is agnostic to any origin. It could be S3, EC2, ALB, or any HTTP server in your data center. So one of the things is the cache miss scenario. So let's say the first time the request comes in, obviously the content is not going to be there in the cache, and the CloudFront will have to go to the origin to fetch that content. And that's what exactly a cache miss is. It goes to the origin sends back the content is now cached. If it is cacheable, it is stored locally in those edge locations, and we send the response back. And subsequently, when a user comes in, the object is already in the cache. We just serve the content from the cache instead of going all the way back to the origin. So that's the cache hit scenario. Now, when we look at Lambda Edge, there are 4 events which come into play. So when a user sends a request and the request is hits the CloudFront cache, but it has not yet checked whether the object is in cache or not, that particular event is called as the viewer request. So this particular event is before it hits the cache and checking if the object is there in the cache or not. Again, this falls in the request path. So let's say if the object is not in cache, it will send the request to the origin, and that's the origin request event. Again, this is all part of the request flow. Now the origin will send a response back. So before the content is cached locally in your CloudFront cache is your origin response event. Now once we get the response, and if it is cacheable, we will cache it, and then we will send the response back to the viewer, and this is the viewer response event. So these 4 events are really critical for you to understand in some of the use cases that we are going to take a look at right now. So as I mentioned earlier, with that in mind, let's take a look at some of the use cases of where you can use the power of Lambda Edge. So the first use case is primarily around security. So we were working with some of our customers, and one of the very common use cases is that when you want to inject certain headers back into before sending the response back to the end users. So in this case, the customer was a financial, it was in the financial sector, and they could have very easily done it at the origin. But because it was a legacy application, they didn't really want to touch it or maintain it. What they instead did was to make use of the Lambda Edge. So in this case, the request comes to the CloudFront cache. It is sent all the way to the origin. And then when the origin sends a response back, but before it is cached, we insert those headers. These could be HSTS headers, CORS headers, or the CSP, the content security policy headers. And then once we have added these headers, we cache those, we cache the response along with headers. And then in the subsequent request, when we serve the response, we serve the cached object along with those added headers, which we just inserted in the origin response. So that's just one example use case of where you can use Lambda Edge. So Julius, can you hear me?
Yes, I can.
Okay, because I was getting a notification saying connecting to audio. So yeah, so the second use case is also around, let's say, the securely accessing origin, right? In this case, what happens is you want to be able to access origin only when the users are allowed or not. So there is obviously so what you can do is you can use signed URLs or signed cookies as a mechanism where you give those users a specific URL or with certain cookies, and only they are allowed to access that content. Or there is also an added protection of using S3 origin access identity to secure that part of your bucket, or using certain custom headers. So you add certain headers before you send the response, so that the origin can do validations if the response is indeed coming from CloudFront, and if not, it can just reject the request. However, there are some customers who might be using some sort of a custom web service, and they want a custom signing mechanism. So in those kind of use cases, what you can do is leverage a Lambda Edge function or the capability. And what you can do here is once the request comes in, the Lambda Edge can add that additional info logic and before sending the request out to the origin. So it can add certain information based on any algorithm, based on certain logic. And then the origin can check based on whether that request is indeed coming from the CloudFront. And only if it is validated, then they can allow it to access the content. So that's another use case for the Lambda Edge. So just a quick, I mean, if you want to read more about this, there is a very good blog post around this, which goes into a lot more detail. So the third use case is for a stateless authorization. So let's say you are using JWT in this case as your authorization mechanism. And the idea here is that when a request comes in, you want the Lambda Edge function, which is running at the viewer request, to check whether the user is authorized or not. And based on that, we will allow the request to continue or not. So if it's a valid user, you would allow the request to continue in its path. And if it's not a valid user, what we can do is you can immediately generate a response from your Lambda Edge function. So you could send access denied, or you could redirect the user to an authentication page. And the interesting thing about this is that you're moving. So this is typically you would be doing all of this logic in your origin server, right? What Lambda Edge allows you to do is allows you to bring that capability or this additional logic out from your origin server to these CloudFront edge locations. And this is especially useful in security. Let's say you are facing an attack, right? It is a massive attack. And with doing all of this logic at your CloudFront edge locations using Lambda Edge, your origin is shielded from all of this traffic coming in. So you don't have to worry about scaling up your origin in these scenarios. So yeah, you can send an error if it is not allowed. And again, there is a very good blog post around this as well, where you can see the example in a lot more detail along with code samples. The other use case is something similar to authorization for stateful. And this is, for example, you're still doing validation, but what in this case, what you're trying to do is you need to make a call to an external service or a store which has a state. Again, this can be done with Lambda Edge, because one of the benefits with Lambda Edge is it allows you to make these network calls. So you can make any HTTP call to any external service. It doesn't have to be in AWS, it could be anywhere. And then that external service can make the decision whether it's allowed, whether it's legitimate, or if it should not be allowed. And based on that response, you could take a request, if it's allowed, to send it to the origin. If not, then send an error or a access denied message back to the end users. So that's another use case of Lambda Edge. So moving on from security, one of the other cool use cases which Lambda Edge allows you to do is content customization. And when I say content customization, template rendering, this is a pretty interesting one because this use case, actually, you don't need to really have an origin. So you're pretty much doing all of your compute directly in the Lambda Edge. So the idea here is that you typically have, let's say, a static content, and then you want to customize this based on certain attributes, based on the requests, or you want to personalize based on a user with certain dynamic content. And this dynamic content could be residing in a different location or a different service. And what you're trying to do here is you're trying to map or put both of this data together before you send the response back to the customer, right? And as I mentioned earlier, Lambda Edge allows you to make multiple network calls. So you can make multiple network calls to different sources, different origins, get these different pieces, and then generate a response. So just what this implementation would look like, for example, with Lambda Edge is a request comes in, right? In this case, what you can do here is you can get the static template from, let's say, S3, and you could get certain dynamic content from your DynamoDB. Again, you can do make multiple network calls from your Lambda Edge. Within your Lambda Edge, you can then formulate or combine those two responses, generate a response, and then send it back to the user. So as well as cache it if it's required, because it can be served over and over again. So that's a pretty cool use case because, as you can see here, there is no compute externally. It's just a storage with S3 bucket, which has your static template and a DynamoDB table for certain dynamic content. And this is primarily just takes away the need to have an origin altogether. The other use case, which is here, is for a website personalization. So let's say in this case, when an incoming request comes in, you also have access to different attributes in the request. So for example, based on whether the end user is coming from a desktop, whether he's using a mobile device, which location is it coming from? Is it coming from a specific country? And what languages they are typically using based on the incoming accept language header. So what you can do is, based on all of that information at the Lambda Edge, you can either redirect them to a country-specific website or to any other location here as well. So this allows you to serve personalized content based on the incoming request attributes. The third use case with Lambda Edge is visitor prioritization. So let's say you have applications where, for some reason, let's say you cannot scale your backend application to meet a sudden spike in traffic. Or the other could be if you want to segment your users across different origins. So what you could do is you could use Lambda Edge function, and which could, in this case, look at a cookie. And this cookie could in turn indicate whether this is a prioritized user or not. And if they are prioritized user, you could send it to the origin. And if they don't have the cookie, then maybe you can send them to a waiting room page for them to come back to the site again in some time when the time period has elapsed. Again, there is a blog post going this into a lot more detail with the implementation sample. So I would highly recommend to take a look at this blog post as well for an end-to-end implementation details. The other use case here is for cache key customization. And I'll give an example around here. So we're working with one of the media customers, and in this case, what they had is that in the URLs for those media content, they also had the playback session ID contained in the URL itself. One of the issues with this approach is that when you have a session ID in the URL, you obviously have to go and get the content from the origin. But this is sending multiple requests to the origin for the same content because the URL is differing for each incoming user. And one of the reasons why they were doing is because they were seeing the access logs for these different customers, and based on what they were accessing, they were able to charge back or track their customer usage. But as I mentioned earlier, for the same content, we had to go and fetch the content from the origin. And this doesn't lead to, this led to a very poor cache hit ratio, because now we had multiple copies of the same object cached. So what we did in this use case was we leveraged Lambda Edge, and we rewrote the URI for a more optimal cache key. So in this case, if you look at it, the sample URL was something like this, which had the playback session ID in the URL. But when we rewrote the URL before serving the content in the viewer request, we removed the playback session ID from the URL. And as a result, there was just one file, in this case for file 1, just cached instead of multiple such files cached for the same content. So this also allows you to do cache key customization, where you need to, if you are getting a poor cache hit ratio, as was with this use case. So moving on, the other use cases around content routing. So in this case, what's happening is you have multiple origins, or different origins. So what you can do here is you can take a look at incoming request properties. So for example, you can look at the URL, the incoming request headers, the query strings, cookies, and based on those, you can send the request to different sources. In this case, you might send some of those requests to London, or you can send it to your own data center. So it allows you to do content-based routing as well, based on those incoming request properties. So the other use case, which is also possible here with this same approach, as I mentioned earlier, is balancing across origins. So we were working with a customer, and what was happening is they would get a big spike of customers coming in, and they wanted to distribute that traffic across to origins in Europe, because they were mainly catering to European customers. So what they did was they had this Lambda Edge function, which inspected a particular custom header, and that header gave an indication of what is the best origin for that particular request, and then they routed it to the appropriate backend origin. So in this case, based on the location, they would route it to the appropriate origin, and then send the response back to the end viewers. So the other use case also possible with Lambda Edge is around data locality or low latency. So let's say you have multiple buckets in different regions, and you want all users, let's say, coming in from Germany to only go to the bucket in Frankfurt, right? So you might be thinking, why not use it natively with Route 53? You cannot do it with Route 53 because of certain limitations of host headers and S3. However, when you leverage Lambda Edge, what you can do is you can have a Lambda Edge function which can look at appropriate values in the request based on the CloudFront viewer country, and then you can route the request to the appropriate S3 bucket in this case. So you can have it routed to different locations. The third use case is around A/B testing, and I think this is a very popular for whenever you are making changes to your website or application, right? You don't want to send all of your users to some change which you have made, because you don't know how it will work. So what you can do is you can use Lambda Edge, and the way it works is you might say, based on the incoming request, to see if this is active session based on, let's say, a cookie, and based on if it's already an active session, you can set the origin based on the value of the cookie. And whenever there is a new session, then you can decide whether you want to serve the A variant or the B variant, and then set the origin accordingly. So in this case, you actually don't send all of your requests or all of your end viewers to just this origin B, which is where you are testing the new functionality, but maybe let's just say 5% of the request will end up going to origin V based on the cookie that you set. This is another cool use case with search engine optimization. And I think I already mentioned about the search engine optimization and why it is useful and how CloudFront can help you. So in this case, we had a customer and what the customer was doing was they wanted to serve the content differently. So they wanted to check whether if this is good part, so it's something coming from Google, Facebook, or Bing in this case. And if it was for one of those good bots, they would wanted to serve a pre-rendered crawler-friendly version of app. If it was a real user, they wanted to send it to their origin. And if it was a bad bot, they just wanted to send a access denied for those bad bots. So this also can help with search engine optimization. And the last use case here, which I want to touch on, is with origin failover. So this is something, origin failover you can do natively without using Lambda Edge. So now CloudFront also supports origin failover. And if your origin failover, as you can imagine, if your primary origin is down, if it sends some error status codes, you can have CloudFront make alternate requests to your secondary origin. You can do the same with Lambda Edge as well. So in this case, you make a request if the origin is down, if it sends a 4xx or 5xx errors, then you can make another request to your secondary origin. And then if the secondary origin is up and running, you can serve the response back to your end users. So that's another example of where you can use Lambda Edge. But again, as I mentioned, this is now also possible natively with CloudFront. So you don't necessarily have to rely on Lambda Edge. So I would say those were the primary, or let's say the different use cases that you can do with Lambda Edge. I think that's all I wanted to cover for from my end. So Julius, I think I'll give the floor to you because I think we had another poll right now.
Yeah, let's just let's do a short poll on Lambda Edge as well, just to check the knowledge. And everybody also please use this time to shoot some questions in the chat or the Q&A section, because we still have some time, and then I think it's very wise to use this opportunity to use Rohan and Ashraf, who also joined his colleague, to maybe discuss some scenarios or give some questions. Okay, and in the meantime, I'm launching the poll about the use cases of Lambda Edge. Please just check your knowledge and an idea maybe that will stick a bit better for you. It's a multi-choice option, so you can choose more than one, because actually, yeah, that's Lambda, as you've seen, at Edge could be used in a lot of very nice scenarios. Okay. And I'm still waiting, I guess, and then Rohan actually for sure waiting for some interesting questions, maybe concerning Lambda. I don't know, maybe somebody is using Lambda and in some scenarios. It would be nice to be shared as well. Actually, Rohan, do you see Lambda Edge already like gaining pace and be used widely among current customers?
Yeah. So I think Lambda Edge is one of the very popular services right now. And I think, as I mentioned, right, there are dozens of use cases possible with Lambda Edge. And I think maybe Ashraf, I think you are there on the line as well, right?
Yeah, I can give a little bit of what I see with customers. So I see customers like using Lambda Edge in different ways. So you've got those customers who are trying to implement, I would say, usual CDN, simple HTTP manipulations, right? So this is one of the typical use cases That can be, for example, to increase security by adding headers, optimize the cache ratio by normalizing the cache key, and so on. So this is like a simple use case for Lambda Edge. Another one is basically when customers are trying to have a completely serverless website, right? So in general, you might want to serve your content from S3, right, using CloudFront, and maybe you want to add some logic before you serve the content. You want to change something in it, but you don't want to implement a fleet of servers to do that. So Lambda Edge that allows you to do that. This is another like typical thing. And the third one is like really customers who are building application from scratch in a completely distributed way because they really care about latency. And typically that goes with DynamoDB global tables and like replicated content across, for example, multiple regions. One of for example, these cases is a URL shortener service that was implemented by a customer. So the customer name is Pernod Ricard. They made the This Is My Architecture video on it. So basically every time you scan one of their like alcoholic beverages bottles, this is a URL shortener that is using purely CloudFront, Lambda Edge, and S3. That I'm sorry, that just CloudFront and Lambda Edge in DynamoDB global table, where Lambda Edge will go to the nearest DynamoDB table and check what is the long URL version and return it as a redirection to the user to go to the website of the beverage that is localized to the country, and if there's any like marketing campaigns to be included in it. So that was a long answer. The short answer then is yes, Lambda Edge is being used by lots of customers in a really different way, from the simple ones to the most sophisticated ones. And if you have a use case that you think is really unique, please let us know. We're really happy to discuss it with you.
Yeah, and I'll share the results of the poll, like where the attendees of this webinar see Lambda Edge used mostly, and yeah, content customization and security seem to be like the best fit. Content routing is also like the right answer. Yeah, and I guess for running virtual machines, Lambda Edge is a bit like just a trick question that we had, and happy to see that almost nobody fell into that trap. I see that there are no questions coming up, so still a few minutes left for that. I don't know, Rohan, is there anything you would like to add at the end, like to summarize all of the stuff that you presented today?
Yeah, I think I would add is that feel free to reach out to us. I mean, via Julius here as well, and we are happy to let's say dive deep into your own specific use case. As I mentioned, the possibilities are endless with CloudFront, and like what we just covered with Lambda Edge. It gives you a lot of flexibility in what you might be doing right now at your origin servers, but you can offload it to the edge locations. Yeah, we are continuously adding new capabilities and features to our services, and I'm pretty sure the next time we have this presentation, the amount of edge locations and the points of presence will have an even updated and a bigger number there.
Yeah, I'm sure of that. Like the number of pods of CloudFront is growing enormously, and I saw that Column is one of the attendees, like the lead for the edge location. So just a reminder, we're really looking forward to having at least one pod in the Baltics anytime soon. And I know it's already coming, so we're looking forward to that. I see a question from Column himself. How can CloudWiser help with CloudFront? So, as I mentioned before, we're specialist AWS CloudFront partners. So first of all, we're really open to helping out from the technical discussions and implementations, especially the ones that require a bit more technical know-how and on how to set things up in the best way, especially what is connected to security, which is one of our main areas of focus. And the other part is actually pricing. I don't know, like, have you checked CloudFront pricing? But once you start using it a lot, especially for delivering media, the standard pricing is gets a bit tough and a bit high. So that's why we could help you out with some special pricing deals. And feel free to reach out to us, like, if you want to discuss this from technical or pricing perspective. It's really, like I said, a very special service for CloudWiser, and we're looking open to that. As there are no more questions, I would like, first of all, I guess, in the name of everybody of the attendees, to say thank you to Rohan for your time and preparation. At least for me, it was super interesting content, and a lot of interesting examples. And from our side, thank you everyone who attended. And I would like to end just with a traditional poll of ours. Just please provide some feedback to us and to Rohan how you like the presentation. I'm just starting the poll, and feel free to reach out to us, and then please join the other event that we'll be having most probably at the end of summer, because everybody needs at least some vacation. So I'm looking forward to mine next week. Okay, I see the poll coming up, and okay, so I'm ending the poll. Thank you very much, everybody, once again, and we'll see you in the next events.
Thank you.
Sure.
Thank you.
Thank you, everyone.
Bye.